Okay, so there is a particle of mass 200 million electron volt by c square. This is the mass of the particle. Okay, this is the unit of energy. It is colliding with an hydrogen. So that particle is coming and then colliding with hydrogen. And then soon after the collision, the particle comes to rest. Okay, and the atom recoils. So now this is going in one direction. Okay, so it is recoiled with some velocity and goes to its first excited state. Apo the electron which is in the first orbit is going to the second orbit. Okay, so the energy of the second orbit is what? Your minus 13.6 by 4, and energy of the first orbit is what? 13.6 electron volt. This is in electron volt, this is also electron volt. So how much energy is needed to go from this first orbit to this second orbit? That is your first excited state. So if you subtract this, you will get 10.2 electron volt. So this much energy is needed. Okay, and then the question is, what is the initial kinetic energy of the particle? Okay, in electron volt they are asking. So we can solve this. So here we can use the energy conservation. So this particle is coming with some energy, with some kinetic energy. This kinetic energy is utilized here to impart some velocity to the hydrogen. So kinetic energy of your hydrogen plus the energy also used to excite the hydrogen, electron of the hydrogen, to the first excited state. Upon this 10.2 electron volt. This is what? Energy conservation equation. About how we can solve this? So this kinetic energy of the particle is half mass of the particle into velocity of the particle whole square, which is equal to kinetic energy of the hydrogen. Okay, so that we can write it as half into mass of the hydrogen, velocity of the hydrogen square, plus the 10.2 electron volt. Now we have to solve this. So here if we solve this, they are asking us what? So they are asking what is the initial kinetic energy of the particle. So here mass of your hydrogen we don't know, velocity of the hydrogen we know. So for this unknown, what we have to do is we have to use conservation of momentum. So the initial momentum will be equal to your final momentum. Apo when it is coming, the momentum will be what? Hydrogen is in rest, so only this will have some momentum. So mass of the particle, velocity of the particle will be equal to, finally this particle is coming to rest, only your hydrogen is moving. So mass of your hydrogen into velocity of your hydrogen. So here we can change the mass of your hydrogen in terms of mass of the particle. How we can write mass of your or velocity also we need now. So we can find the velocity of the hydrogen. So velocity of the hydrogen will be what? Mass of the particle, velocity of the particle divided by mass of your hydrogen. So this we can use. So we can bring this left hand side, half we can take in common. So here we will be having mass of the particle, velocity of the particle square minus mass of your hydrogen. Okay, then velocity of your hydrogen. So what will be the velocity of your hydrogen? Now only we got that answer. What is that? Mass of the particle square, velocity of the particle square divided by mass of your hydrogen square, which is equal to 10.2 electron volt. Okay, so here in this equation we have to find what? Velocity of the particle. So here if you see, we have two unknowns. What is that? So not unknowns. Okay, mass of the particle, mass of the hydrogen. So here mass of the hydrogen is also given. Okay, mass of the particle is also given. Just substitute all the values, we will get the answer. Okay, or directly we can substitute this here and we can get the answer. So like this if you solve, finally we should get, okay, we should get this velocity of the particle should be your 51 by 4 electron volt. Okay, this you check it. So here this n will be nothing but your 51.